Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Today on the bench we have a Harman Kardon Citation 1 vacuum tube preamplifier that's pretty well known in the audio circles. What we're going to do is restore this thing and bring it back to its former glory yet again. Now, just like every other piece of gear that ends up on my bench, it usually has some form of a story to tell. So what we're going to do is go through this thing and see how it's been treated through the years, see what kind of repairs have been performed, and we'll even analyze its design. So let's see what this thing has to say for itself. Let's get started. Here's a close look at the face of this Harman Kardon Citation 1. And what this is telling me so far is that either this unit has been living with an owner that's really taken good care of it, or this thing has spent most of its time in a box. I'd easily rate the condition of this externally about an 8.5 or 9 out of 10. There are very few flaws. A little scratch down here I can see, and some minor scuffs on the paint. Now this has just come straight out of the box. I haven't done anything to this. I haven't cleaned it up or anything. And as you can see, there is some surface dirt. So really, when the thing's cleaned up, it's only going to get better. So it's in very, very nice condition. If you're thinking of purchasing a preamplifier like this, one of the things to keep your eyes open for is the lettering and the numbering on the face here. For some reason, I find that people love to drag their fingers on the face of these things and carve the lettering and the numbering off, and that looks really ugly. So if you buy a unit where that's happened, be prepared to either re-silk screen this or find something that's aftermarket to replace it. This, again, is in very nice condition. People have actually grabbed these knobs like they're supposed to, and they haven't been dragging their fingers on it. On the bottom here, we have a channel A and a channel B. So basically, you can choose whatever channel you want to be right or left. It has independent bass and treble controls for each channel. We have a turnover control, a roll-off control, a blend, and a low cut here. Really interesting feature of this in the roll-off control is we have an LON setting, which stands for London. So if you're going to be listening to records from Europe, you'd want to put this on the London setting. Kind of neat. Over here we have a bunch of switches, contour, tape monitor, stereo reverse, and phasing control. One of the things that always caught my eye about these preamplifiers is we have all of these knobs that are made out of aluminum, but down here we have this weird kind of plastic, almost not really see-through, but kind of a diffused plastic knob. Whenever I see this, I always think of an insert to one of these aluminum knobs. It looks like an insert that would fit inside, and there was supposed to be an aluminum knob on top of this. But this is just the way they came. So when you see this little plastic knob down here, it's not actually missing a cover or anything. That's just the way it is. Over here we have our volume control or loudness control, and our mode setting, function setting, and a balance on the bottom. So all in all, it's a really complete preamp, and it's got lots of different settings, so you can really tailor the sound to the way you like it. Nice versatile preamplifier. So what I'm going to do is turn this thing around and we'll take a look at the back side. Here's a look at the rear side of this Harman Kardon Citation 1. And as you can see, like a lot of modern pieces of audio gear, there are lots and lots of input jacks here. So these are all RCA jacks. So everything is pretty much self-explanatory on the back here. We have input channel A and B here. And we have input channel A and B here. So we have all of these different inputs for all of the different selections on the face of the unit here. We have the outputs over here. We have two outputs for channel B and two outputs for channel A. So these would run off to the power amplifier. And another neat feature is it also has a center channel amplifier output right here. There's a bunch of switched outlets here to run external audio amplifiers and whatever piece of audio gear you want to have. Maybe a record player, or if you wanted to use a CD or a tape player, you could plug these all in here. And these outlets will be controlled by this switch on the face of the unit. So when you turn that on, these three here will get power. This one here is unswitched. There's always 120 across this one right here. These are all the vacuum tubes under the shields here. And let's see what kind of vacuum tubes these things have. They look like Telefunken. Yeah, made in West Germany. Yep, Telefunken vacuum tubes right there. So I'll remove all of the shields here in just a little bit, and we'll take a look at all the vacuum tubes. I'm imagining they're probably all going to be close to this. The tube shields are in nice condition as well. As you can see, they're not rusted or anything like that. So as you can see, this thing is, I say, very, very nice condition. So whoever owned this thing has definitely done their job in keeping it in very good condition. I notice on the top here that I can tell this lid has been removed at one time. Now, that's most likely due to the reason that on the side there's a sticker here, and it looks like it was serviced in 1964. So what I'm going to do is turn the preamplifier again here, and we'll take a look at those stickers. As you can see on the side of the unit here, there are a bunch of stickers. This is dated 12/28/1964, so obviously this has seen some form of service. It says authorized factory service here. So it will be interesting to look under this cover and see what was done and see what a story this thing has to tell under there. You can tell it's been open because the screws have kind of marred the paint here, and it's been shifted a little bit. So the cover has definitely been off, and that's noticeable on the top side of the unit here as well. So it'll be interesting to take a look inside this thing, and that's what we're going to do next. In order to get under the top cover here, I need to remove 2 screws from this side and 2 screws from this side, which I've already done. Now all I need to do is remove these 4 screws on the top, and we should be able to get under this top cover. So let's experience this together. Let's see what's hiding underneath this. So notice I'm doing this very slow because I don't want to scratch the paint on this. I'm guiding this with one hand and holding this with the other. Now the fasteners that they've got on the bottom side, as you can see, are really chewing the screws up, so chances are I'm going to replace all of these screws. Probably use some stainless ones or something like that. Maybe even use some small washers on here to cover up the marring. We'll see how that goes in the end. And you can tell it's really biting the screws. Just by dropping the screw, you can see all the little metal flakes coming off. Just the fasteners that they're using on the bottom side there. Get all these off of here. All right. What's underneath? Here we go. Wow, that's actually looking pretty original. Doesn't even look like anybody's been in here before. I'll just put the lid over here. So what do we see? Lots of bumblebee capacitors that will all be electrically leaky, so these will all need to be replaced. These ceramic disc capacitors will be absolutely fine. These can all be left alone. There's no reason to replace these at all. So this is brown, black, yellow, which is 104. So that's 0.1 microfarad with the yellow band, meaning 400 volts. So these will all get replaced. All the electrolytics look original, so those will have to be replaced as well. These are real troublemakers in anything of this age, so those will all have to go. Work on something to maybe keep the originality, leave these in here, and maybe put something underneath the chassis or something like that. We'll come across that here in just a little bit. So yeah, looking really nice. Everything is so nice and clean in this thing. Very impressed. Not much tampering, if any at all. All right, so this is only one side. Let's flip this thing over and take off the bottom cover and see what's on the bottom side. Maybe that will yield something different. Who knows? In order to get into the bottom cover here, there's just a bunch of screws that need removing. This one here, this one, and this one, and this one. And the bottom comes right off. And when I remove the bottom, this This thing looks incredibly clean inside. It doesn't look like anybody's ever been in this thing. So I wonder what that sticker on the side is about. Put the lid over here. Nice heavy bottom cover. So again, all of the original Bumblebee capacitors here have to be removed. There's a red marked Sprague here. These are dye-film capacitors, and they usually don't leak. But since I'm in here, I'll replace it anyways. If you ever see a Sprague capacitor with yellow writing on them, they're very bad for leakage. They have to go. Again, since I'm in here, I'll just replace everything. Over here's another little Bumblebee. This is 0.01 microfarad, so 103, and then 400 volts. That'll go. You can see all the original diodes and fuse holders here and everything. It just looks so incredibly clean. Again, I don't think anybody's been in this thing. I'm really wondering if this thing did spend its life in a box. Original line cord on it. It's nice and soft. There's no cracks to it. You know, nice and soft here. No issues whatsoever. Very nice condition. All the original capacitors aren't showing any physical leakage on the bottom whatsoever. They're still sealed up nicely. So again, these will all have to be replaced somehow. We'll go over that here in just a little bit. Figure out how we're going to put some new capacitors in here. So yeah, all in all, contacts are also clean and everything. So this is a very nice example of a Harman Kardon Citation 1. So this is channel A on the bottom side here, and on the upper side is channel B. So what I'm going to do is turn this thing back around, and we're going to start replacing these Bumblebee capacitors with a suitable replacement that should be dependable for a very long time. I'm about to start the replacement procedure for all of these Bumblebee style capacitors on channel B here. I'm also going to replace this dye film capacitor right down here. I'm going to talk a little bit more about the orientation of this dye film capacitor in just a little bit. So when we get to replacing this, I'll cover that then. Now I've made a few other observations about this preamplifier, and one of the things that I've noticed is in the assembly procedure of this preamp, they used quite a combination of both carbon composition, this is known as an Allen Bradley style resistor here, and they're also using carbon film resistors. Now you might be thinking to yourself, well, it looks like somewhere along the line somebody's been in here and done quite a bit of replacement. Well, if we look at the binding posts here, all of the solder is the same color between the carbon composition and the carbon film resistors everywhere. It doesn't look like anything has been resoldered throughout time whatsoever. Even the flux that's on the binding posts to the carbon composition and to the carbon film resistors is all the same color throughout everywhere here. So wherever I find a carbon film resistor or a carbon composition resistor, all the soldering is looking relatively the same. So it's kind of an interesting thing to note about this particular preamplifier. Another thing to note is this preamplifier wouldn't have worked very well due to this resistor right down here. I noticed that looking at this a little bit closer here. What I'm going to do is I'm going to zoom in the camera on this little component here, and I'll be right back. Here we are zoomed into the circuit quite a bit closer, and if you look at this carbon composition resistor here, it's broken. So what can we learn about the failure point of this resistor through visual inspection? We'll take a look at this end of the resistor first. So we can see that the resistor's body itself has got a nice crack in it, and you can see that there's a nice light brown sharp edge where it's cracked. There really is no evidence of any kind of burning or sparking at that end. If we look at the lead-in wire to the resistor itself, you'll notice that there's a little bit of carbon at the end of the lead-in wire. That's completely normal. That's where the lead-in wire is inserted into the carbon plug within the resistor body here. You'll notice beyond the carbon, there's a clean area right to the ridge up here. That clean area is where this lead-in wire is sealed into the brown portion of the body, and that little ridge sits right at the resistor's body edge. You'll notice that the lead-in wire itself is on this angle here, whereas the resistor body itself is on a different angle. You'll notice that the lead-in wire itself is very short to a very fixed point. I'm pushing on that, and you can see there's almost no flexing on this end here. So this terminal tie point or terminal lug is very, very solid. Whereas at the opposite end of the resistor, this lead here is tied to a vacuum tube socket. And what I'm going to do now is wiggle the vacuum tube. What does all of this tell us? Well, we know now that the resistor itself has broken through mechanical stress. Now, whether this preamplifier went back, way back when, to an audio service place, like we saw that sticker on the top cover, or whether this was a manufacturing default, or whether this has happened through time, we really don't know because there's a cover on this whole area here keeping the dust down. There's very little dust in here, and if we look at the resistor body itself, it doesn't look like there's any dust on it at all. Now, what I can tell through removing the vacuum tubes off the chassis, so I'll wiggle the vacuum tube here again, the tubes themselves are very tight within the tube sockets, which tell me that there hasn't been a whole lot of tube replacement in this preamplifier. And in a little bit here, I'm going to go over that and I'll show you what I mean. You can really tell how a preamplifier or receiver or anything with vacuum tubes has been treated throughout time, basically just by the condition of the tube socket itself. And I have some stories about that as well. So what I'm going to do to fix this problem is replace this resistor with another carbon composition resistor. Now the resistor that I'm going to replace that one with is a little better quality than what was in there. You can see this red band right here. That means that this has got a 2% tolerance, whereas this resistor here has a 10% tolerance due to the silver band. Whenever you're going in any piece of tube gear like this and repairing it, you want to make sure that what you're replacing in the unit is better or equal to what came out. Now, nowadays it's really kind of tough to know what you're buying when it comes to resistors and capacitors unless you buy from a very reputable source and you know that the resistors and capacitors are not counterfeit. There are so many counterfeit resistors and capacitors on the market today, it really is quite astonishing. Now, a lot of people like to get into these things and replace all the resistors with metal film resistors because they think that they're quieter. If you don't get your metal film resistors from a reputable source, you may in fact be making your preamplifier quite a bit noisier. So something to keep in mind. I'm about to start replacing the Bumblebee capacitors on channel B here, and there really is a whole bunch of ways to remove these capacitors. Many of those ways really just depends on the tools you have and how clean of a job that you really want to do. Now, before I get started in actually taking these things out and showing you my method here, I'd like to talk a little bit about component lead stress and noise. So any of you that have owned vacuum tube audio gear over the time, and even some solid state audio gear as well, you've noticed that as the unit gets older, sometimes they develop some hissing or crackling, sometimes some random popping noises. Now, a lot of these problems are contributed to component lead stress over time. Now, when I'm talking about lead stress, if you take a look at this capacitor in circuit here, you can see that they've taken the lead and they've pulled it tight around this binding post number 42 here. They've also done it on this side here. Well, when you're putting the component in and you're wrapping leads, a lot of the times it actually pulls the binding posts together a little bit, putting continual, like a spring tension, on the component's lead. So it's actually trying to pull the leads out over time. And much of the time, that actually happens to resistors and capacitors. It may not be quite noticeable, but even just the slightest little bit of pull on those leads can cause a hissy, staticky connection within the component. Now, I've demonstrated this in some of my other videos. I've located some hissing, noisy components, and again, most of the time, this is just caused by component lead stress. Now, Tektronix, way back in the day, they did a whole bunch of things to alleviate these problems. What they did on their larger oscilloscopes is they would install ceramic tie points and they would cut the leads of the component before they were actually dropped into the ceramic tie points So there was no mechanical lead stress, and then they would solder them in. So the component is basically just laying there, and then they solder the actual binding posts or the ceramic strips. Now that's very good practice to follow whenever you're designing or building anything or replacing components like we're going to do now. So after I've removed these components, what I'm going to do is cut the leads short, and I'm just going to solder the leads directly to the side of the binding posts. I'm not going to wrap them. So there will be no mechanical lead stress on the component whatsoever, and over time it won't be pulling on those leads. Now, much of the time, the reason that they've wrapped these things around these posts really isn't for mechanical rigidity or anything like that. It's just because one person is putting these things in the circuit board or on this actual tie point board on an assembly line, and then there's another guy that's actually doing the soldering down the line. So whoever that person may be that's doing the soldering down the line doesn't have to think. All they have to do is just put solder on, solder it, and then it's off to the next person to test. And that's the reason that they do this wrapping. It's really basically for speed. It has nothing to do with mechanical rigidity. Like, I mean, this thing is not in a high vibration atmosphere, and it's, way back in the day, it wasn't flying around on a plane or, being driven around in a car or anything like that, right? This thing just sits on a shelf. So there is no real reason to put this mechanical lead stress on. Now, if you were to replace all the resistors on this board, it would be a very time-consuming process because you're not going to be wrapping anything. You would be installing one component, laying it up against the actual binding posts themselves, and then soldering them in. And when I put the new components in, I'll show you exactly how I do that. The tool that I'm going to be using to remove these capacitors is a very sharp, small clipper. So I picked these up quite a while back, and I'm very happy with them. Now you got to be careful with these things. You really don't want to be cutting any large diameter wires or anything like that. But for this type of work, these things are great. So this is an EREM 776E. Now what I'm going to do is I'm going to use the binding post itself to work against to unwrap this lead. So what I'm going to do is get this onto the post like this, and I'm going to pull the lead away from the post and basically unwrap it. So that's the nice thing about having a sharp clipper like this. You can see that I'm already starting to pull this lead away, and then basically what you do is you just twist it, and it's almost kind of like you're basically peeling it off. And look at that. Very easily comes off, and I didn't even have to desolder anything. Now on this end here, I'm going to do the same thing. Now, as I say, your technique may vary. You can see that, how that works. And it's very simple. You're really not putting a whole lot of stress on anything here because you're just peeling the thing off. And you can see how easy that component just came out. All the Bumblebee capacitors in channel B have been replaced, and we'll take a look at that here in just a moment. Something very interesting to note about these Bumblebee capacitors: when these were made, they were very careful to mark the bands on this in the correct direction. So where the rating starts, 104, the brown band indicates the outside foil end in this capacitor, and this is consistent with all of these capacitors, and even these ones out of an old piece of Hewlett-Packard gear. So at the end that the rating starts is the outside foil. Now oddly enough, on the channel B card, every single one of these capacitors was backwards in circuit to the way it should have been installed, aside from one. We'll take a look at that here in a moment again. So in order to demonstrate the outside foil end on this capacitor here, the green LED will be lit with the lowest amount of signal on the oscilloscope indicates the outside foil end, and I'll demonstrate that right now. So I'll just clip this in here. And I'll put a little bit of noise into the circuit with my hand. So let's see if I can get my... So you can see there's noise in it right now. That LED indicates the outside foil end. that's the lowest noise. So when the LED is lit, that end is applied to ground or to the common here on the case and the coax. Now, if we look at this end, that is the brown band, the beginning of the rating. I can do this, and so you can see that's just me putting some noise onto the capacitor here, coupling some 60 cycle hum into it. Really is what I'm doing with my body. I'm acting as a hum antenna. So you can see the minimal amount of noise is at this end, and this is very consistent with every single one of these capacitors. So I'll grab one of these out of another piece of Hewlett-Packard gear, and I'll put this in the opposite way. So the brown band is now at this end. So this LED should indicate now the lowest noise. So I'll just grab this. A little too close to the leads at the end there. Try and make this viewable with the LEDs here. So you can see lowest signal there, brown band here again. Marking the outside foil end. Now, with all of these capacitors, I've done the same thing. I've taken time to mark the outside foil end. You can see I put a little dot here, right on the end. So that marks the outside foil. And these capacitors run down the line any old way. So you can see that I have the writing both in the same direction. Yeah, one has a dot on this end, this one here, and the other one has a dot on this end here. Alright, and to demonstrate this, I'll just put this in a little test jig here. Try and get this out of the way. And you can see that this end is the outside foil end. And if we look, you can see the little black dot there, so that's marked. And if we were to install this one the same way, it should be the exact opposite, because this end is the outside foil end here. Way. And there you can see it's nice and quiet on that end. So again, this is the outside foil end right here. So when I've installed all of these capacitors in there, I was very careful to note that, and we'll talk about that here in just a moment. Let's take a quick look at Harman Kardon's design and discuss what they did with those original Bumblebee capacitors. So before I get started, I've replaced all of the Bumblebee capacitors with these capacitors right here all the way along. This is a good name brand, Illinois Capacitor, and I know that these are going to be good for the long run. Now before I installed these capacitors, I made sure that I knew the outside foil end of each capacitor. Now every one of these capacitors along here has the outside foil end at this end of the circuit, aside from this one capacitor right here, and I'll talk about that here in just a moment. Now when Harman Kardon designed this, they took the plate leads and made them the long runs. So the plate lead is here, you can see it runs all the way back to here, and then this is the plate resistor here, which is a 68k ohm resistor. This is the correct way to design things. So what you want to do is you want to keep the grid leads as short as possible, and if a run has to be longer, it should be at the lower impedance portion of the circuit, and the plate of the vacuum tube is the lower impedance portion. So that means that this end here is the outside foil end. Now, as you can see, all the way along here, I've put a little dot on the inside of the capacitor here, so you really can't see them in circuit. But if you look here on the end, you can see that little dot right there. I do that to all of these capacitors. Now, these capacitors run down the line any old way, and they each have to be tested to indicate or to find which end is the outside foil end. So, as you can see, I have two capacitors. The writing is the same way here. The outside foil end is on this end right here, whereas on the opposite capacitor, it's on this end here. Now, this one capacitor here is the only capacitor that's opposite of all the rest. Now, in order to keep everything looking uniform, I tested a whole bunch of capacitors and basically marked them. So what I did is I took one of these capacitors like this with the outside foil on this end and installed it this way, whereas all the rest of them, the outside foil end is here, just to make things look uniform all the way across. Yet, again, the dot is on this side of this capacitor, whereas on all the other capacitors, the dots are all on this side here. What I'm going to do is print out a capacitor map for this particular preamplifier, and I'm going to put it into an attachment, and I'll put a link just below this video here, and I'll mark that. So if you're interested in having the capacitor map for this, if you want to make sure that your capacitors are all installed the correct way, just go to that link and it'll be a free download there. So you'll see that I haven't changed this die-film capacitor here yet, and that's because I wanted to talk about that. This end here is the ground end, so you can see there's a whole bunch of grounds attached to this end here, and then this end runs off. As you can see, on this die-film capacitor, there's a red band here. The red band is the outside foil end. Again, the outside foil end always goes to the lower impedance portion of the circuit, and that is tied to the ground end. So this is installed correctly. Now, why they installed all of these capacitors this way in the circuit is beyond me. They should have actually been installed this way all the way along. This one here would have been the opposite way, and then all the way along again. These would have all been like this if they were installed correctly. Now, I've looked at pictures of other amplifiers just to refresh my memory here, and many of them are installed the correct way. It's just this one here seems to have them all installed this way, and it's the same on the other side as well. So very interesting, very, very interesting. At any rate, that's all corrected, and these things are now orientated in circuit the correct way, and I'm going to do that on the opposite side as well once I change this die-film capacitor out. Changing the capacitors on the bottom side is a little more difficult than the caps on the upper side, just because there's a few obstructions in the way. There's two pipes here that are carrying wires, and there's this little choke that needs to be moved out of the way. There's a bumblebee hiding on the underside here. Tip this forward, you can see the bumblebee right there. So in order to remove this, it's pretty simple. Just remove the nuts and the bolts here and move this out of the way. And you really don't need to take any of these nuts and bolts off. You can just move this around as you're desoldering the capacitors here. So not too big of a deal. These are pretty flexible. This is sunk down into the chassis here just a little bit. If you can see that, you see the tube sockets here. Now this is kind of sunk down. So again, a little bit more difficult, not a big deal. And again, all the capacitors are the wrong way in here. The brown band should be at this end here. Again, aside from this capacitor here. So that'll all get corrected, and I'll also replace this die-film capacitor here, and we'll move on to the electrolytics. All the bumblebee capacitors have been replaced on channel A, as well as that die-film capacitor. And now it's time to focus on the electrolytic capacitors here on this chassis. Now, for aesthetic reasons, I'm going to leave the original capacitors in because they're in very nice condition, and there is no signs of any physical leakage on the bottom here. Again, this thing looks like it really has low time on it. So what I'm going to do is install the new capacitors on the bottom side of this little chassis here. And what I'm going to do is remove the wires from the original capacitors here and install some ceramic standoffs and fasten the new capacitors to the ceramic standoffs. And when I have them all installed, I'll show you exactly how I've done that. Now, whenever you're replacing an electrolytic capacitor, you cannot leave the old one in circuit just because common failure point of these capacitors is they short or close. Now, of course, if this capacitor shorts and closes one of the original ones and you have the new one tied to it, the new one really doesn't mean anything because, this thing just turns into a jumper to ground. So you want to make sure that you always remove the old capacitors from the circuit. You can never leave old ones in and then, basically just parallel new ones. It doesn't work. Now, this particular capacitor here has only one capacitor inside the can. You can see that they could have put 3 capacitors in here, but there's only one pin really populated on the bottom of the can here. So there's one cap in this can, there's one cap in this can here, There's 2 capacitors in this can with a common ground, and in this can here there's 3 capacitors with a common ground here. On the side of the can is a legend. You can see that there's a triangle, there's a kind of a square or rectangle here, and then there's a half moon over here. If you look on the side of the can, there's a legend, and it tells you what each capacitor does on the side of the can. So if it says, say, 40 microfarad at 450 volts, and then there's a little triangle beside it, that means that that triangle is that particular capacitor, and so on all the way around. And a lot of the time you'll see on the can it says can COM negative, so that means that the can is negative. Now, in some cases, the actual can is isolated from the capacitors, and there'll be a ground or a common on the bottom of the can, but it'll usually tell you that on the side of the capacitor as well. So that's why you see these little squares. You can see a little square here, over here, you know, again, rectangle here, and then a triangle, and then a half moon. And you can see they've got them marked here as well. It's just that they're not populated. And it's the same down here. So if I was to move the pins, you'd see the other legends as well. So that's what they do with these older can-style capacitors. Now, these capacitors are usually 80, 85 degrees, something like that. The new capacitors I'm putting in are 105 degrees C, and they have an extremely long hour rating at that, so they're very robust capacitors. And another nice thing about installing them on the bottom with standoffs is in the future, if they ever need to be replaced, these are modern capacitors, and you can just get under here and replace them very, very easily. A lot of people like to restuff the cans, so what they do is they cut the old capacitor open on the top, and then they put the new capacitors in the can and then reseal the can again. Well, that's all fine and dandy, but one day down the road, they're electrolytic capacitors, and they're going to probably need to be replaced again. So why not just make it easy for the next replacement and keep everything nice and clean looking? So what I'm going to do is start going on the installation of the capacitors on the bottom side here, and when I have everything installed, I'll come back and I'll show you exactly how I've done that. All the new capacitors have been installed into circuit, and they're soldered to the ceramic standoffs. All the old capacitors are disconnected from circuit, and they're basically just acting as supports for the new capacitors. In a moment, I'll zoom on into this and we'll take a closer look at what I've done. I still need to replace this bumblebee capacitor here. This is across these diodes. This is 0.01 microfarad at 400 volts. And I'm also going to replace this ceramic capacitor that's across the line cord. I'm going to replace this with a modern safety capacitor. This is very, very important to do whenever you're working on an older piece of equipment like this. These older capacitors aren't designed to open when they fail. A lot of them close. The newer safety capacitors open, so that makes things quite a bit safer. So this is an absolute must. You need to get rid of these older ceramic capacitors that are across the line cord. The older the piece of equipment, the scarier the capacitors are. A lot of the older vacuum tube radios, older vacuum tube amplifiers, and even older test gear have paper capacitors across the line cord and from the line to the chassis. This makes an incredible shock hazard present, so that definitely has to be addressed. I'm going to do an entire video dedicated to safety capacitors and installing them in older equipment here in the very near future. So something to definitely keep in mind. You'll notice that on a piece of older equipment like this, it has a line cord, but it is not polarized. So this line cord here can be plugged into the wall this way, or it can be plugged into the wall this way. Now, in a lot of older equipment, there's a capacitor across the line and from the line to the chassis. So depending on which way it's plugged in, if one of those capacitors, say it's a paper capacitor, is shorted to the chassis of your unit is live. Very, very dangerous. So again, in the near future, I'm going to do an entire dedicated video about safety capacitors. So what I'm going to do here is zoom on in and show you what I've done with all of these electrolytic capacitors here. So you can see I've soldered in the ceramic standoffs to the old capacitor pins here, and they're even soldered in the center, so this is incredibly sturdy. The little standoffs are on an angle like this to keep the connections away from the chassis. If I tip the chassis here a little bit, you'll be able to see that. You can see how they're angled. And it's like that with all of them. They're all on an angle. They're sticking up like this. This one here as well. And this one here is mounted straight up and down. So the old capacitors are just acting as supports now for the little ceramic standoffs, and all the new capacitors are soldered to the ends. So it makes a nice clean modification. You just basically take the wires from here, put them to here, and then solder in your new capacitor. This makes for very easy replacement in the future. You can see how easy these would be to replace. You just clip a bunch of wires, take it out, and put a brand new capacitor in. Now, these are very high quality capacitors, and I doubt that these things are going to need to be replaced for a very, very long time. But still, it's always nice to think ahead and, prepare for the future. The 0.01 microfarad bumblebee capacitor across these diodes has been replaced. And I've also replaced that ceramic capacitor across the line cord with these two safety capacitors. Now, the factory capacitor is actually two 0.01 microfarad capacitors in one case. Now, it says here 2x 0.01. That's not to be confused with an X2 rated capacitor. All this means is that there's 2.01 microfarad capacitors in this case. Now, those 2.01 microfarad capacitors are in series, and I have two other capacitors here. I'll show you what I mean here in just a moment. These capacitors rarely fail, but they need to be taken out of the line cord application. So these need to be removed because this is not a safety cap. So what I'm trying to tell you is you don't need to throw this part away if it's still working. You can throw this thing in your junk bin, and you can use this in a non-safety related application. So this capacitor here, if we were to look at two safety capacitors and we were to just basically solder the two center pins together. So if I was just to take these and solder those two pins right there together like this, this is basically what this is like this. That's all. So just two ceramic capacitors in this block, basically in series. And that is how this is hooked up here. One lead is to here. We have both of the capacitors soldered together here, which would be the center lead of this capacitor. And on this end here is the other end. And that's basically what's going on. So now that that's done, what I need to do is get behind the face here and replace the dial lamp. That'll be the next step. That's a pretty simple step. All that needs to really be done is you have to remove this screw here, and then if you flip the chassis over, there's another two screws, and just pull off all the knobs. They're on splined shafts. Take all the knobs off, and the face will just come off, and we'll replace that dial lamp. Once you've removed the four screws from behind the faceplate, so there's a screw here, and then there's one on the bottom here and one on the bottom here. All you have to do is remove the knobs. They're all on splined shafts, so they should come off relatively easy. Now, when you replace the knobs and put the knobs back on, there really is no indexing. So what you want to do is either turn the shaft over to one side and then line the pointer up to one of the markings. There's a bunch of different ways of doing this. If there is a center mark, a lot of the times what you want to do is align it to the center mark, and then it should follow when you move it either way. There's a bunch of different ways of doing that, but still relatively easy. Now, throughout time, I've come across all sorts of different situations. I've had people glue knobs on, and that's absolutely horrible. There's no reason to do that. If these knobs are loose, you can take a screwdriver and very carefully, slowly bend them. If you try and put too much force on them, a lot of the times you'll break one of these right off. So you have to do this very, very carefully, and even more carefully with the aluminum shafts. So again, you can stick a screwdriver in there, very carefully part them. Again, they break very easy, so be very careful of what you're doing. Just go at this very slow if you're going to try and part these. There's another way of securing a loose knob on a shaft. If you're worried about it being too incredibly loose, you can take a little bit of just any kind of cellulose tape, cut a small strip, and then just put a small strip over this and then put the knob back on. And a lot of the times the cellulose tape will give enough area or take up the slack so that it gets pretty tight after that point. So there's a bunch of different ways of going after this. Definitely don't ever try to glue or even use any kind of a hot glue or anything to hold the knobs onto the shaft, because the next time you have to get in here to change that dial light, you'll be teaching yourself a couple of new words, I'm sure. So once those screws are all removed and all the knobs are off, this just very simply comes off like this. And this is a very good excuse to get in here and clean the face of this. Now, when you're cleaning the face of this, you always want to work on an inconspicuous area first, and you want to use a very mild detergent. If you're unsure of what you're doing or what you're using, don't clean the face, because there's nothing worse than taking the lettering off. So again, very mild detergent, and always test it in an inconspicuous area. So the dial light lights up our very out of place looking knob here. I'll just zoom on into this. So behind this little washer here, this is just to stop it from shining through the face and shining into the knob. There's a little bulb in this holder here. So all you need to do is just remove the screw right here. This whole thing will come out and you can replace the dial lamp. And this dial lamp will again illuminate this somewhat out of place looking knob. Once you've replaced the dial lamp, which is an 1815 or number 1815, you're going to want to check to make sure that it works before you put the face and all the knobs back on. There's nothing worse than putting something all back together and finding out that you've installed a dud for a dial lamp, and it does happen. I've come across my fair share of them. If you put your entire unit back together and you found out that the bulb is still not glowing, there's another thing you need to check before you take the whole thing back apart again. The dial lamp itself in this unit is in series with the filaments of V5 or vacuum tube number 5. So if the filaments in that tube are open, the dial lamp will not glow. They are in series. So one thing to keep in mind. Another thing before you go putting the face back on, you're going to check to make sure that all of these nuts on the shafts are tight. Over time they do back off and get a little bit slack, so sometimes you'll find that you get a loose control and maybe a wafer switch or a potentiometer might rock back and forth when you're moving a knob. So another thing is just tighten these up. Once you've cleaned everything in here on the face, inside here, another thing that you're going to want to do just before you put the face back on is put a drop of light oil right on the shaft where it enters into the potentiometer. And that'll keep everything nice and lubricated and moving smooth for a long period of time. Now, you don't want to saturate anything with oil. Basically, you just want to put a drop right where the shaft or where the little retainer ring is, where it enters the potentiometer or wafer switch, and that oil will leach into the shaft area here where it's inside, and it'll keep things moving smoothly so that they don't seize up or get rough. After that, you're pretty much ready to put the face back on again. One of the ways to tell how much time there is on a vacuum tube device, or to get an idea of how it's been treated throughout time, is to remove a vacuum tube and basically feel how tight the tube is within its socket. So I'll give you an example here. All the tubes on this chassis are very tight. So what I'll do is I'll just gently rock this tube as I'm removing it. You can see it doesn't really want to let go of that vacuum tube very well. That's a nice tight tube socket. And all these little contacts in here haven't been stretched apart. Now, if you find that when you're pulling the vacuum tube out, it basically falls out, chances are you're going to want to replace that socket, or at least try and pinch these little contacts back together again. If you have a small jeweler screwdriver, a lot of the time you can stick the jeweler screwdriver between the actual socket itself and the contact and push them back together. So again, the better option would be to replace the actual tube socket so that it makes proper contact to the pins. Now, another thing that a lot of people don't know is that some of the newer import vacuum tubes, I guess you could say, have smaller pin diameters than the older vacuum tubes. So if a device has had an older vacuum tube in it, and you put a newer one of these import vacuum tubes in there, a lot of the times they're just loose because, again, the pin diameter is smaller. So that's another thing to keep in mind. Now, that's not necessarily a bad thing. I find that a lot of the newer vacuum tubes with these smaller pins, the pins are almost polished, and they make very good contact when they are in the socket. Again, they're just a smaller diameter, so they will seem loose when really the socket is probably okay. At this point, we're just about ready to try out this preamplifier and see how it works. One of the things that I want to do just before I do that though is clean all the potentiometers and the wafer switches with a very good quality contact cleaner. This is very important. If you don't do this, all the dust that's settled into these little controls over time will make staticky connections, and even in the actual wafer switches, sometimes you get an intermittent connection. So what you want to do is take your preferred contact cleaner of choice. You want to make sure that it's a pretty high quality contact cleaner and that it's suitable for being sprayed inside of potentiometers and on open contacts on wafer switches. You want to take that, and spray a liberal amount on it, and then just work the controls on the face of the unit. So basically you're just moving the contacts in and out a bunch of times and give them another spray. And usually after that, pretty much soak up the rest of the residue and you're ready to go at that point. So that's what I'm going to do next. That'll take a little bit of time because there's a lot of controls and I have to work each control and make sure that I get the contact cleaner into all the contacts. The restoration procedure for this Harman Kardon Citation 1 is pretty much complete at this point. There's just a few minor things I need to do before I put the covers back on. One of those things that I'm going to do is replace these pieces of tape that are coming off the wires here. They're just using tape to loom the wires together. You see right here and right up here. So I'll replace those with some modern zap straps. Now this is something that you want to do right in the end of the restoration or repair. I know a lot of people, they want to keep everything clean as they're going along and keep the wires nice and tight and loomed. But the thing is that in the end, if you're testing something and there's a wiring error, or say you need to trace a signal or something by separating the wires, you're just going to end up clipping up all of your brand new zap straps. So again, something that's just done right in the very end. Now, the testing procedure for a preamplifier like this is extremely time consuming, and this thing has been running on the bench for probably 4 hours now. The things that I'm looking for is noisy, staticky resistors and noisy, staticky tubes and noisy controls and things like that. So this has gone through a complete test at this point of both channels, and what I'm going to do is just shorten this up and give you an idea of what I'm doing here. So I have a 400 cycle signal running to one of the inputs right now, and that's that yellow alligator clip that you see back there. The white alligator clip goes to this signal tracer, and the signal tracer is just acting as an audio power amplifier. That's really all the signal tracer is an audio power amp with a very sensitive front end. I did a restoration on this Heathkit Model T3 signal tracer in an earlier video, and there was actually some design errors in this thing that I corrected as well. That's in that video. So a very handy signal tracer to have around, especially when you're testing preamplifiers like this. An oscilloscope is a must as well, and I'll cover that here in just a moment. So I have that hooked up to one of the outputs, so just one channel right now, and if I advance the loudness control or the volume control, you'll hear that tone. That's coming out of the speaker on the signal tracer right now. Now, that's a 400 cycle tone or very close to. You can use a 1000 cycle tone or whatever you're comfortable with to test this. Now, another test that's very important to do with an oscilloscope is you want to check the amplitude of both channels with the balance control centered. You want to make sure that the amplitude is very close to being the same with the balance control centered. If it's a little off to one side, just a touch off to one side, not too big of a deal. But if you find that the balance control is way over here, to get the amplitude the same on both channel A and channel B, chances are there's a faulty resistor in the circuit somewhere, or you have a bad vacuum tube. So what you're doing is you're bridging both channel A and B inputs together, and you're looking at the outputs separately on a dual trace oscilloscope. And in future videos, I'll go through this in more detail. Again, a very time-consuming process. One of the things that catch people when you're working on preamplifiers is the really sensitive gain stages. So we have a Phono 1, Phono 2, and Tape HD here, and they're all extremely sensitive. Now, you can't test these stages with the bottom open like this. You can see how I've got the yellow and the white alligator clip in there. You need to have all the covers on the amplifier, and you need to test the preamplifier like it would be operating in normal service. With the covers removed, it's very susceptible to hum, and it could lead you astray to thinking that you have a problem with a vacuum tube or something like that, when really the reason it's humming is just because the covers are missing. So something to keep in mind. So all of the controls have been tested on this. Again, just hours of operating and moving things around. The step controls here have been tested and everything. You know, all the switches have been moved around. Everything is nice and silent after the contact cleaner. It's running nice and cool. There's no issues whatsoever. Everything is working perfect. The sine waves are really nice and clean on the oscilloscope, and the amplitude is very close. So all in all, I'm very happy with the outcome of this preamplifier. It's working extremely well. Thanks for stopping by the lab today. I hope you enjoyed this video. If you did, you can let me know by giving me a big thumbs up and hang around. There'll be more videos coming like this in the near future. So if you haven't hit the subscribe button, you might want to do that as well. If you're interested in taking your electronics knowledge to the next level, I have an ongoing electronics course on Patreon right now. This is dealing with solid state and vacuum tube electronics alike. I'll have the link just below this video right about here in the description. So if you click on the link, it'll take you right there and you can check it out. While you're there, you might want to check out the community section as well. There's lots of people there sharing their projects. So until next time, take care. Bye for now.